All right, guys, today this is called a tree graph, and that's because this is like the trunk, and then these are the branches, and it's all related. These are actually categories of what I'm going to be talking about, which is proportional relationships. Now, in class, I drew a similar thing, and right now we're going through proportional relationships and different ways of proving it. And so the first way we talked about was unit rates, right? You could simplify all these down to a denominator of 1 to prove it, right? So all these simplify down to 10 over 1, 10 over 1, 10 over 1. And that proved that these rates are proportional. They're all equal if you simplify them down. The other way that we talked about in class was like this. We said, I'm just going to copy it down again, 10 to 1, 20 to 2, 30 to 3, 40 to 4. The other way was we looked at this and we said, well, look at this. For every hour, right, it grew $10. Is that true? Yeah. All right, why? Because when I babysit, I get paid $10 an hour. So that means for 2 hours, I'm going to get paid another $10. And then for 3 hours, I'm going to get paid another $10 for 1 more hour. Another $10 for 1 hour. You see that? And this is called a constant ratio, constant rate. It's growing at a constant, I'm just going to call it a constant ratio because I'm kind of thinking of it as 10 to 1, 10 to 1, 10 to 1. This is another way to prove that there is this proportional relationship. All right, let's turn. You should be copying this. No, don't put your head down, copy it. And then we went into graphing. So here's our x, the y-axis. And if we were to graph that, it would start at 0 and probably climb something like that. And because it's a straight line, and because it started at 0, we know that all of these rates are actually equal. And then later we're going to talk about how it actually climbs or we'll talk about slope later. Today we're going to talk about another way to prove proportional relationships, or prove that the relationship is proportional. But first of all, these are all talking about the same thing. We're trying to prove something. And so let's go over to now solving, this next video is called Solving Proportional Relationships. And I'm going to show you another way of proving this. And probably a lot of you are going to be like, Mr. Toth, why didn't you just show us this in the first place? And that is because my goal is always to help you understand. All right, let's make sure I'm on the screen. There we go. Let me look at my notes. All right. So we're now going to go down to one word. And yes, copy this. Proportions. Proportions. Is it proportions or proportion? Well, let's just do proportion. A proportion is when we know already that one rate equals another rate. So we know that 1/2 equals 4/8. Is that true? Yes. Or we could think of it as 1 to 2 equals 4 to 8. And so I'm going to show you, a lot of people call it a shortcut. I've even heard it called the magic box. Those are all nice ways to remember it. But what I want us to, there is a way to prove that these are equal, and it's called cross products. Cross product. So what does product mean? It means you're multiplying. And cross products means this. It's kind of like cross canceling, but cross products. What it says is that if you multiply 2 times 4, it should equal 1 times 8. If they are proportional. You see that? If they are proportional, then when you multiply across, or x, right? You like that? x, could be a butterfly too, but let's just take the x, cross products, they should be equal to each other. And look at that. Is 2 times 4 is 8. 1 times 8 is 8. Is that true? Yeah, it is true. It is true. In fact, let me read you the definition. A proportion is an equation stating that two ratios or rates are equal. So we're assuming that these are equal. And then, because of that, we can do cross products, which is, that's a fancy explanation. The products, or multiplying these two and these two, should be equal. So, how does that help us? Well, let's do a few more of those. Let me look at my. See, am I safely on the screen? Yeah, let's try another one. All right. Well, we know that what 2/3 is equal to what 4/8/12. Those are the same. If I simplify this, right, we know that's 2/3. So we're going to assume that we know these are equal. So this is a proportion, right? How can we prove that? Through cross products. All right. 2 times 12 equals 3 times 8. 2 times 12 is 24. 3 times 8 is 24. It's true, isn't it? Is that true? Yeah, we just proved that cross products proves that they are proportional or equal. So we now can add that to what? Turn my little camera to this. These are all ways of proving something has a proportional relationship. So let's come back to here. How much time do I have left? Oh, I'm doing pretty good. Let's erase. So how is this helpful? How is this better? Let's do 2 more. I want you practice cross products on these two. We know that 2/4 equals what? 10/20, right? And we know that 3/5 equals 15/25. These are proportions. We know they're equal. You prove it at home. All right, pause. Show me how to do that. Nice. Nice job. We know that 2 times 20, since they're proportional, equals 4 times, 10. Right? That's 40 equals. Is that a true statement? Yeah, it is. All right, how about this one? Cross products. We already said these are proportions. They're equal. So that means if we multiply them across, it's really an x. They're equal. So 3 times 75 equals 5 times 15. I made a mistake. 3 times 15 equals 3 times 25. See that silly mistake? Well, wait, what do we do wrong here? 5 times 15, sorry, and 3 times 25. There we go. See? Let that be a lesson. It's really easy to mess that up. All right. So that's what's that? 75 equals 75. Well, nice. Nice. All right. So that's, how do we use this? Well, let's all turn to page 56. Page 56. Let's get back on the screen. Page 56, number 1. We're going to, look what it says. After 2 hours, okay, after 2 hours, so you know this is hours, the temperature in the room raised 7 degrees Fahrenheit. Write and solve a proportion, and because it says solve a proportion, it means that we already know they're equal. Write and solve a proportion to find the amount of time it will take at this rate for the temperature to rise to what? To 13 degrees. So on the bottom is degrees, so here, I'm going to write 13 here. And what they're asking is this: how long? We have 2 hours, it raises 7 degrees. How long will it take to get to 13 degrees? So they want to know the time, so I'm going to put T here. Now, I don't know. And you see how it's not friendly to like go from 7 to 13? And I could go down the unit rate and solve it that way, but look at this. We know that cross products, if they're proportional, are equal. Therefore, let's do it. 2 times 13 equals what? 7 times t. Is that an algebraic problem that you used to? Sure. So now we have 26 equals 17. Am I doing this right? Right. Yes, I am. And now, okay, well, we got to solve for t because that's the unknown. So what is, divide that by 7, divide that by 7, and now we have t equals what? What is that? 3 5/7. Is that right? I think so. So how long will it take it to raise to 13 degrees? 3 5/7 minutes. Or they put it in a decimal, which is fine too. Did I do that right? Make sure I got that right. Yes. 3. All right. Do you see how that worked? By doing cross products, I was able to find my answer. And now I could have taken this to unit rate and then multiplied it by 13. But here's another pathway. All right, let's try another one. That's how it can be used. Kind of nice, huh? So in fact, let's try. I want you to try, if you look on the same page, A, B, and C. Look at A, and I want you to pause in between each one. If you look at A, let's apply this. They're saying solve each proportion. Therefore, we know they're equal. So we know that x divided by 4 equals that. All right, how do you solve that? Using cross products. Pause, try it. All right, well, you should have done this. 10x, right, equals 4 times 9. All right, 10x equals 36. What's the inverse of multiplying by 10? Divide by 10. X equals 3.6. Nice. Let's try B. It says 2 to 34 equals 5 divided by y. Yikes, there's a variable on the bottom. But we can do it. Why? Because we know it's a proportion. We know they're equal. Therefore, cross products is our new best friend. So cross products, we know that 2y equals what? 5 times 34. All right, therefore, I'm going to work down. In fact, I'm not going to do, I'm running out of time here. Get back on there. All right, let's solve for y, divide by 2. Whoops, I should have multiplied that. So 5 times 34 is what? 22, 15, 17. That's what. Divide that by 2, so we know that y equals 170 divided by 2, or 85. So that y is 85. Go ahead and solve C. I'm not going to solve it for you. I'm just going to give you the answer. C is 49. If you should have set it up and solved it. So that's how you use cross products. So let's do a few word problems. And if I run out of time, I'm going to do a second video, but it will be super short. Let's go to page. Let's go to page 58. All right, we're on page 58. And there's 3 of them. So we have k over 7 equals 37 over 56. We have 3.2 over 9 equals n over 36. And we have, what is this? 41 over x equals 5 over 2. These are, look what it says. The instructions say solve each proportion. And because it says that, that means that these can be solved using cross products. So I have 50 seconds left. So let's set these up. So we know that 56k equals 7 times 32. See that? Can you solve it from there? Sure. We know here that 9n equals 3.2 times 36. Cross products. Here we know that 5x equals what? 41 times 2. All right? Please watch the next video. Don't try to get out of it. I only had 19 views last time. I need 25. Actually, you need to watch it.